All right, welcome to The Explainer. Today, we're diving into a really deep one, maybe one of the most fundamental questions in all of artificial intelligence. How can an AI ever truly understand the world? I mean, not just crunch numbers, but actually get what things mean. The answer could honestly change everything we think we know about intelligence itself.
So let's start with what seems like a simple question. How does an AI really know what a rabbit is? Sure, we can feed it millions of pictures of rabbits, we can label them all, and it'll get incredibly good at spotting one in a photo. But does it understand what it is to be a rabbit? Or is it just a master at matching pixels? As you're about to find out, this seemingly simple question, well, it throws us right into a philosophical rabbit hole.
And that, right there, leads us straight to the brilliant 20th century philosopher W.V. Quine. He came up with this amazing thought experiment. Imagine you're in a foreign land, and a local points at a rabbit scurrying by and says, "Gavagai." Okay, easy, right? Gavagai means rabbit. But how do you know? What if it means a fleeting rabbit moment, or maybe something super specific like the collection of that rabbit's parts that are currently attached to each other? From just watching, you can't be certain. This chasm of uncertainty is what's known as the Quinean abyss, and it's basically the root of AI's symbol grounding problem.
So what's causing this abyss? Well, to get to the bottom of it, we have to talk about the linguist Ferdinand de Saussure. He pointed out that the connection between a word, what he called the signifier, and the actual concept it points to, the signified, is totally arbitrary. There's nothing inherently rabbit-like about the sound or the letters R-A-B-B-I-T. We all just agree that's what it means. This arbitrary split, this Saussurean gap, is the real villain of our story. It's why symbols inside a computer are just empty tokens with no built-in meaning.
Okay, so here's where things get really interesting. What if we didn't have to build a bridge over that gap at all? What if we could just collapse it? That's exactly what this new framework proposes. Instead of trying to connect a word to a concept, it merges them, creating an entirely new and much more powerful foundation for meaning in AI.
Look at this. On one side, you have the old, broken model, that fundamental disconnect we've been talking about. The word and the concept are separate. But on the other side, this is the big idea, the process sign. Here, the sign is the process. The meaning of rabbit is no longer some static definition in a dictionary. It's the entire dynamic, unfolding experience of a rabbit. The hopping, the nose twitching, the way it darts away. The process itself becomes the sign. The two are one and the same.
So here's the absolute key. A process sign is a unit of meaning that's defined as a recurring pattern of experience. Think of it like the unique melody of an event. The AI watches the world and learns to recognize these melodies of experience, like the specific rhythm and tempo of a rabbit hopping. It then captures that melody as a kind of mathematical shape, a prototype curve. And just like that, meaning is no longer an abstract label. It's a tangible, verifiable, time-based pattern.
And this idea doesn't come out of nowhere. It actually fits perfectly with the work of another giant philosopher, Charles Sanders Peirce. For him, a sign had three parts. A process sign nails all three. First, it's iconic, because the computed curve literally looks like a picture of the event's shape over time. Second, it's indexical, because it's a direct trace caused by the event, like a footprint left in the sand. And finally, it becomes symbolic, because you can give that pattern a name and use it in abstract thought. But here's the kicker. It does all this without ever losing that direct, grounded connection to the real world.
Okay, so we've got our new weapon, right? A sign that closes Saussure's gap and is grounded in Peirce's logic. But is it tough enough to take on Quine's legendary paradoxes? These philosophical dragons? Let's find out how it systematically defeats them.
All right, this is where the rubber meets the road. Let's go down the list. First up, that Gavagai problem, which philosophers call inscrutability of reference. How do we know it means rabbit and not rabbit part? With a process sign, it's no longer a mystery. The AI just checks which experiential melody best fits the data. The melody of a whole rabbit hopping is a very different shape from the melody of just an ear twitching. It's a direct comparison. Next, underdetermination of theory. What if two different stories could explain the same event? The AI just uses a simple, elegant rule. Prefer the theory that gives you the best explanation using the fewest patterns. It's all about data compression. Finally, confirmation holism, the idea that all our beliefs are interconnected. Well, the process sign AI is built that way from day one. Its knowledge is literally a graph of these interconnected patterns that updates as a whole every time it learns something new. And just like that, the dragons are slain.
I mean, let's just stop and think about what this means for a second. The huge takeaway here is that reference, that fundamental link between a word and a thing, it's not some deep, dark philosophical mystery anymore. It becomes something you can actually compute. The question stops being an ambiguous "what does this mean?" and becomes a testable "does this new experience match one of my known patterns?" Meaning gets grounded in the very shape of reality unfolding.
Now, this is way more than just a cool philosophical victory lap. Solving these incredibly deep problems of meaning has profound, real-world consequences. It gives us a practical blueprint for building a completely new and different kind of artificial intelligence.
And I know what you might be thinking. Okay, great theory, but does it actually work? Well, the answer is yes. This isn't just an idea on a whiteboard. This framework has actually been put into practice. And it's shown that AIs can discover concepts directly from raw data without a human programmer having to spell them out.
And the proof is pretty wild. It comes down to this number, 3. So check this out. In one study, researchers had an AI analyze gamers' physiological data, things like heart rate and muscle tension, in the moments after their character died in a video game. But here's the thing, they didn't tell it what to look for. By clustering the time-based patterns it found, it autonomously discovered 3 completely different emotional realities of in-game death. One was a sharp spike and quick drop, which it basically identified as startle quick recovery. Another was a slow buildup of tension. And a third was pretty much no reaction at all. The AI didn't just find patterns, it discovered new concepts all on its own.
So let's just lay it out. What kind of AI does this new foundation actually create? Well, first, it would be far more robust and adaptable, because its knowledge isn't a fragile list of rules, but a flexible library of real-world patterns. It would understand the world not as a static database of facts, but as a collection of unfolding stories and scripts. It learns concepts directly from the messy, raw flow of experience, not from a programmer writing code. And maybe the coolest part, its knowledge base becomes autopoietic, which is a fancy way of saying it's self-creating and self-maintaining, constantly refining itself to better fit the world.
And this quote, I think, just sums it all up perfectly. We're talking about moving away from an AI that sees the world as a static photograph, frozen in time. This is the blueprint for an AI that understands the world as it actually is, a dynamic, ever-unfolding story.
And that, of course, leaves us with a huge, mind-bending question for the future. An AI built like this wouldn't just learn the concepts we teach it. As we just saw, it would discover its own concepts, its own experiential melodies, straight from the data. So, what happens when an AI's story of the world becomes richer, more complex, and maybe even more nuanced than our own? That's a question we're all going to need to start thinking about. Thanks for joining The Explainer.